This video shows how to find the determinants of a matrix using cofactor expansions. For an example, if we consider the matrix A is the size of 3 by 3, and we want to find the determinant of A using the cofactor expansions, we're going to use this formula here. So the determinants of A equals to little a11 times big A11 plus little a12 times big A12 plus little a13 times big A13. In this example, we're going to use the first row of matrix A to find its determinants. So what are little a's and big A's? First, if we look at little a11 is the entry on the first row and the first column of A, which is 7 in this example. And if we consider little a11, we can find the minor m11. So the minor m11 is formed using the original matrix A and delete the row and the columns that contains the value entry A11. So first we start with matrix A, and then in order to find the minor M11, we delete the first row and the first column of A. So the remaining matrix is the minor M11 here. Once we have the minor M11, we can find the cofactor big A11 that associates with little a11. So big A11 equals to negative 1 raised to 1 plus 1. 1 is the row order, and this one here is the column order. So negative 1 raised to 1 plus 1 multiplies to the determinant of M11, and M11 is actually the minor M11 that associates with the entry little a11. Again, the cofactors big A11 equals to negative 1 raised to 1 plus 1 times to the determinant of M11. So how can we find the determinants of this matrix M11, which is the 2 by 2 matrix? Let's remind us, if we have a 1 by 1 matrix, then the determinants of that matrix is just going to be is only entry A11. Okay. If we consider a 2 by 2 matrix B, which has entries A, B, C, D, then using the cofactor expansions, the determinants of B is gonna be equals to little b11 times big B11 plus little b12 times big B12. First, little b11 in this example is A, and then big B11 using the definitions of cofactors is gonna be equals to negative 1 raised to 1 plus 1 times to the determinant of the minor B11. So the minor matrix of B11 is gonna be the matrix after you delete the first row and the first column of B, which is just the matrix 1 by 1D. Okay. And then similarly, little b12 in this example is actually B. And then big B12 is a cofactor of B12 forming using this formula here. You take negative 1 raised to 1 plus 2 times to the determinant of the minor. And the determinant of the minor of B12 is formed by delete the first row and the second column of B. So the remaining matrix is just going to be a 1 by 1 matrix C. And we know that the determinants of a 1 by 1 matrix is entry, and similarly the determinant of the matrix C is just going to be C. So At this point, we form the formula that helps us find the determinants of a 2 by 2 matrix B by taking the products of the diagonal minus the products of this diagonal. Right. Turn to the previous example. We wanted to find big A11 using this formula, and then now we know how to find the determinants of M11, which is the determinant of this 2 by 2 matrix, using the products of this diagonal minus the products of this diagonals, which gives us the answers of 1. 1 times 1 minus 0 times 5 and times 2 1, which is give you 1. Okay. Now back to our original matrix. Again, we want to find the determinants of this matrix here using cofactor expansions. At this point, we know how to determine or how to find big A11. Using the formula here, you will get 1. And then similarly, we can find big A12 using this formula, -1 raised to 1 plus 2 times the determinant of the minor. And the minor matrix here is formed by deleting the first row and the second column of A. So then the remaining matrix is -1, 5, 2, 1. And the determinants of this matrix is -1 times 1 minus 2 times 5, which is -11 times -1 here to get +11. Lastly, big A13 is equals to -1 raised to 1 plus 3 times the determinants of the minor A13. So the minor A13 is formed by deleting the first row and the third column of A, which gives us this matrix -1, 1, 2, 0. And then we know how to find the determinants of this 2 by 2 matrix by taking the products of this diagonal, -1 times 0 minus 2 times 1, which gives us -2 times 1 in front, which is -2. So now we have all the information that we need in order to find the determinants of A. So little A11, which is 7, multiplied to big A11, which is 1. Plus little A12, which is 3, times big A12, which is 11. Plus little A13, which is 2, times 2, big A13, which is -2. Computing these sums and products gives us the determinants of A is 36.